because these are the mathematical equations. It is taken from the literatures. We are not going to peer review them at this moment, but increase of thermal conductivity due to permeation of dry air. There is the equation they are using it. Okay, increase of thermal conductivity due to permeation of water vapor. There is the equation they are using it. Okay. Next, let's go to the accelerated aging one. That will be interesting. Unless somebody has got a preference in detail.
Sorry.
Okay. To determine the average value of the thermal conductivity over the first 25 years, the use of accelerated aging is used. The underlying principles are described in clause 2.3.1. The first procedure for VIP without any desiccant is described in 2.3.2. The presence of desiccant in the VIP requires a modification described in C.2.3.3. We'll go through that. As standard conditions, 23 early, the increased rate of thermal conductivity time is usually rather low. So accelerated aging condition at higher temperature and humidity are chosen, where the permeation of air and water vapor through the envelope is enhanced considerably according to equation C7. Also the increase of thermal conductivity is accelerated accordingly. Okay.
So the issue I got there is we keep talking about impermeable materials. And then we're gonna age it where we're expecting air and water to flow through, and I think what they mean by envelope, it's not building envelope, it's the envelope of the VIP. And if air and water vapor is going through the envelope of the VIP, we don't have a VIP. You have no vacuum if you got air flowing through.
That's why there is a desiccant and getter is there. They absorb that. As long those molecules are not free, you still have lower vapor pressure.
Okay.
So it's at least we should say air and water vapor flowing into the VIP, not through it. Are they, do they go in one side and go out the other?
No.
Okay, so it's not through the envelope, it is, well, I guess if the envelope is one side. Okay, yeah.
The envelope has two sides.
See, going across it, it will need a differential condition. One side is another, another side is another.
Yeah, and you have a negative on all sides. Okay. Okay, never mind.
Nice.
Okay. The method A section is used to declare the thermoconductive VIP test specimen per product thickness of different. If method B section C1 is used to declare the thermoconductive VIP test specimen in 10 mm thickness to VIP specimen 40 mm thickness for different production dates and shall be used. The VIP test specimens are stored in 50-70 or 50-70 and 80 days. At the start of the storage, 30-70-80 days. The government storage is 180 days. Thermoconductivity is measured according to ISO 8301. The average of two samples with sample thickness is calculated. Also, the inner pressure P as well as the mass M shall be measured for control purposes and cross check. Okay. From the average values of these thermoconductive 60-80 days, the steady state increase is calculated. From the determined value of the inner pressure weight between 60 days 80 days, the annual increase of inner pressure, annual increase of weight related to the calculated compare measure the increased thermal conductivity as a counter check. The reason for using measurement interval 60-80 days for the calculation of the thermal conductivity increase is to eliminate the effect of short-term mechanisms such as outgassing and changes of the solid conductivity becoming negligible after 60 days. A typical example measured values with some thickness bigger C2, the increase of 60 days is typically higher than observed afterwards. After 60 days, the thermal conductivity is approximately linear function of time. The slope of this linear function is this shall be determined by least square feet method measured values 60-90 days accelerated. Likewise, corrected thermal conductivity shall be determined as interpolation to be the best fit of T is equal to 0.
So, method A and method B, we struck those.
Yeah.
So I don't know if we have to rewrite those or we just delete those. Up a bit more. Yeah, second one, if method A from section 1 and method B from section C1. So
Okay.
basically, this is gone.
The first is
And this we turn into saying the thermal
Thermal
conductivity shall be declared from 2 VIP tests, and so on and so forth.
Okay. I'll rephrase that one, okay? Okay, so method A is taken out, method B is rephrased, okay?
Yeah, now on the note, it's in normative language.
Is the note in the normative section is not mandatory?
Well, if it's note, it can't be mandatory.
It cannot be mandatory.
So we either make it just part of the standard, which I think is probably the better thing to do, or we change the wording to say you don't have to do this. But if you wanna do it, or you wanna take this into consideration.
Is a counter check is a mandatory part?
I think it should be.
I think it's a simple thing to do. We are doing so many complex things. It's a simple thing to
And
do
that one you can just simply delete note and you're okay.
Okay, it's not to make it a mandatory, take the note away. Because the whole process is not that straightforward,
Yeah,
but.
you can leave all the wording and you
Okay.
just take the word
I'm
note
just
out.
taking the scratching out the note.
Yeah.
Okay, and change the font so it will be a regular part of it, okay? We are okay with it? The interior thermal conductivity is related to penetrating of dry air, okay? So they are taking only the aging due to the lambda change due to the air. Now with gas, with the catering, supposedly it should be very little, because now air is also gone, isn't it? So air is gone, vapor is gone, right? But practically it will still age, isn't it?
Slightly.
Okay, slightly. Okay, so what could be the reason for that? Do you have some data to say that one without any gator, can you make some panels, say with glass fiber, okay? Glass fiber is quick to see that how it's changing. With a one with no gator, no desiccant, okay? Another with only gator, another with gator and another with only desiccant, another with gator and desiccant both. If you can, because I have got some students working with me, if you can send, say 5 panels of each type of this, okay, we can go through the accelerated aging test in the lab. You can also repeat the same thing there. Then we'll have 2 sets of data, and we can do it for 30 days, okay, and see that what kind of results we get. Can we establish these factors? We can introduce. The one is lambda is when only due to the air. One is lambda that when air and moisture both are going in. Okay. Another is when none of them are going, there will be still some aging, isn't it?
I have a data on such kind of experiment.
You have it?
Yeah.
Okay. Can you show it to us? I can give it to you. This is interesting part. This is where we are stopped.
23 degrees Celsius, and aging condition is 50% humidity. And this is this working document condition, 50 degree, 70% range. And the other condition we also perform there. The VIB sample, number 1 and number 2, number 3, number 4 is graph fiber, and the envelope is different, and desiccant and Gators condition is also different. Number 1 contains only desiccant, and number 2 is also contain Geta 2. Okay. Number 1 and number 2 is according to this document, air permeation effect is you can see this data, and Geta's effect is you can see from the number 2. This is number 1 and number 2 is
Has been constant.
data. Number 1 is line is 23 degrees Celsius and 50%. This document is 100 to 80 days test, and a linear increase, and 50 degrees 70%. The slope is change, and the increase is higher. Of increasing of thermal conductivity is higher. This condition, and this is due to the air permeation. The water vapor through the VIB envelope is captured by desiccant. This is desiccant and Gators data. So only slightly increase, but thermal conductivity.
First one is desiccant only. Okay. Second one is desiccant and Gator.
Yeah, is the desiccant, and this is the desiccant.
So
and Gator.
aging and this thing is very slow, isn't it?
Yeah.
Okay. These 180 days, 40, 90, 80 dry was the worst condition, isn't it? According to your test, 80 degrees centigrade.
80 degrees Celsius. Yeah.
Okay, 80 degrees centigrade, highest temperature, but you have got temperature and humidity both.
Yeah. And
But
air,
that
air permeation is accelerated by temperature.
temperature.
Yeah.
But high humidity, maximum humidity you had,
And humidity is different, and
57.
red line and yeah,
The right side.
green line, and this data not different. So this data shows water vapor is captured by
Is captured by
desiccant.
desiccant.
that's again, that's very important.
This data shows yeah.
Okay. So that 2350 means 23 temperature, 50 RH, isn't it?
Yes.
50, 70. 50, 70, yeah, 50, 70 is high.
50, 70,
also,
Yeah.
That's high, it all makes.
This
It's
is,
a lot size.
size is different.
Size
It's a bigger.
No, I understand, yeah. But you have 50, 70 same size too. That red, hollow, that's at the same size. Yeah,
Ah.
that's all.
Yeah.
Yeah. Okay. So if the size increases, That makes sense too, because size increases,
The
the
value will be,
permeation will be in a volume to surface area ratio,
yes,
so that will reduce the total permeation rate too. So with getter, okay,
constant.
is the aging which you are getting here, is there any change there if you increase the scale, or it's going randomly? Those values on number 2, okay, those are they consistently slowly increasing, or they just go randomly experimentally?
Continuously, slightly
Increase.
decrease.
Slightly.
Yeah, because getter can also
The molecule get more.
The effectiveness of the getter might have, the effectiveness of the getter changes as it absorbs more and more
Yeah.
gas or vapor molecules, isn't it? Both for the getter and desiccant, the effectiveness of it changes as it absorbs more and more particles.
The speed is not different, and the amount is not different.
Yeah.
But the gas molecule contains argon, and the getter can absorb the argon, such kind of air molecule. So, but the air molecule, the argon's content is not so high, so just slightly increase.
Okay, so that will be useful. So we can, using this information, so we have got the confidence that getter actually improve the performance. Okay, so we can replicate the same thing, add a section there, where we will say that we'll give that a name, though it is slow, we still have a process to give a effective aging rate or something like that, and using the same function what they have got desiccant, and we can say combined effect of something combined factor, which is much lower than the effect of the desiccant, and use the same equation in another section. That will solve the problem.
Okay.
Just have the slightly increased slope.
Can you send me the copy of this one?
Okay.
Yeah.
So when I look at this, what strikes me is, I wanna buy this panel. Okay,
It depends on the price, maybe.
could depend on the price, but this may be an area where we have type 1 and type 2.
Yeah.
So if I wanna buy type 2 for argument's sake, because it's cheaper, at least I'm aware that the aging is gonna have a more profound effect than buying the most expensive one or a more expensive one.
But I just have only one question. So have you ever tested for a very long term, when the getter maybe saturate?
Yes, I have tested.
Yeah. Then after that, it will maybe turn
It
away.
is true for getter and desiccant.
Yeah.
Both for them, if you keep on exposing, exposing, eventually you'll get a
Yeah.
very high increase.
Because yes.
Yeah. And getter and the desiccant have the lifetime, and so
This has got a limit.
Yeah.
Beyond that,
Yeah.
it's
if the getter and desiccant is
So because
saturated,
this company had told me that they want to do some materials maybe will last for 100 years.
possible.
So in that way, you should have a long-term test about this materials, this products, or not.
See, if you, so for
So
example,
for example, for 100 years, if both two materials have the same effect, because at the end of when they saturate, they have the, even though they get the same value at that time, so there's no advance for me to take the second one as the first one. So just the wiser thinking is not about the standard here.
Is it difficult to Getter and his cutter at the same envelope?
No,
No.
Just,
it's difficult, is not. Getter and desiccant
One
both are
simply-
in
simply
the powder
the-
form, it's just a mix. Is the increasing the getter increase the cost? It costs,
Yeah.
it's very
Mhm.
expensive.
Yeah, okay, yeah.
Cost is that?
I will be expensive, yeah.
Yeah. And what is your product? This type or this type?
This time.
Panasonics.
Sonic,
Yeah,
both of them.
yeah,
This
both of.
Ah.
Do you produce this type?
Commercial
This
product.
with getter?
Yeah,
You
yeah,
produce.
we produce, yeah.
But the panel which you gave it to us, see, those are without getter.
No getter,
No getter.
yeah.
But still those are performing now 7-8 years. There is no significant sign of aging.
Okay.
Yeah.
Or in the lab you can pick up those couple of percentage aging, but on the field it's very difficult to pick up a couple of percentage aging.
So for my benefit, if I'm buying this product, you're gonna have an initial R value,
Yeah.
or U value, I should say.
Mm.
Okay, and do I have it right in the worst case condition at 50, 100, 200 years, pick the number, whatever it is, it'll never go below what I would test in a, I think we use the term punctured panel or damaged panel.
Yes,
So
yes.
we lose a vacuum and we got these pieces together, we're gonna have some sort of U value. That's the worst case condition.
That's the worst. That's the punctured value, that's the failure value.
And I
Basically
think-
that's a disaster management.
Yeah, so in a standard, we talked about that, so we've added initial U value for the
And
testing.
the punctured value,
We have the
aging
worst
value.
ones, so what we're really talking about here is,
declared R value.
how do we go from here to here, and, you know, what sort of shape is that
Yeah,
line?
yeah.
Oh, that's one.
So there are two, we are basically in the current, this SAN standard, there is two, one with desiccant and another without desiccant, okay? Here I have got a little concern because, you know, when you say that silica fume itself is a desiccant, okay? Glass fiber you may say that it doesn't have any desiccant properties, you know, very little, but fume silica can absorb the water, okay? When they are saying without desiccant, that means without additional desiccant, okay? But, and that's why you see that some of the effect what you see in the fumed silica, and don't see, though they say that glass fiber, it is a combined effect, because glass fiber expand quickly and converts the nanopores to micro or macro pores. That's why you see glass fiber pore sizes changes because thickness increases more quickly. Fumed silica has got more mechanical
Stable.
compactness, so robustness, it doesn't change. So that may be another effect, but another effect could be, particularly in the lower level, it could be because of the these desiccant properties which fumed silica has, glass fiber doesn't have it. Maybe, I'm not sure, but glass fiber with desiccant also ages fast. Mostly it's the pore size changes. Okay, that's a nice piece of results, I think. I think you presented it there, isn't it? When you, not
First
this
time.
one, I'm saying first time there.
Mm,
I remember this one, I didn't remember that. Maybe I missed it, Okay, thank you very much. Please send it to me, that is very interesting. I've never seen someone did that. Okay, so that solves a lot of my problems. I was thinking about the getter one. So I will fine tune that one, I will look into that. And if you can work with this one with me, to add a section, that will be helpful. Okay, next we can move to section C3, the determination of linear thermal resistance of vacuum insulation panel.
The key here is we gotta put it into normative language,
Which one?
C3. So we say the determination of linear thermal transmission is usually carried
So
out.
those are, I have noticed it, they are not careful about it. I will make sure may,
Yeah.
shall, can be, usually,
Yeah,
those
it
are
is
the-
strongly recommended, it shall.
shall.
Other than that, I didn't have comments on that, so.
By numerical simulation according to ISO 10211, it is strongly recommended to use the finite difference method because of, I think this one they took it from ASTM, better accuracy and greater tolerance of the size and shape of the numerical cells when simulating the thin component layers of the envelope materials. Numerical modeling should take into account even smallest gap fills with air or sealing material between two panels. The used details of the boundary conditions have to be documented carefully. The determination of linear thermal transmission value can be done by measurements of the guarded hot plate and guarded heat flow meter. As well, if additional measures take the non-uniform temperature distribution within the surface of the VIP assembly with joints into account. Therefore, two VIP are assembled within the GHP or HFM apparatus so that their joint is within the metering area. Temperature sensor have to be placed directly on the joint area. Certain the width and influence of the areas depend strongly on the cross-section conduction of the barrier layers. Cover layers and the sizes of the VIP shall be selected big enough to area and the measurement temperature different areas to be area weighted and average before calculating equivalent thermal conductivity result for the VIP. The measurement has to be documented carefully. The following sketch illustrates the different principle of measurement. The procedure is similar to procedure given in the EN 1934 for the HFM measurements of machinery. So I have to convert this to ISO document, EN 1934. Any comment on this? This is taken from another standard, so there is nothing new there. So ISO standard will be converted to a, no, already converted here,
Yeah, what are they?
8990. Tony has done that, and I had a old REM copy. Okay. Picture is missing. Okay, note 1. When using HFM method, special precautions have to be taken to avoid assessment of the thermal. So maybe we'll take the note part away because these are the useful information, isn't it?
Yeah, it's sort of,
Take the note.
always think of it, what is it gonna tell you as a manufacturer that you have to do? If it's just for nice information, let's move it to an informative annex
Mhm.
that you can read whenever you feel like it.
Because these are the special precautions has to be taken. These are the part of the test method, isn't it?
You know, and they're using the term have to be taken, well, we gotta change it shall be taken. Once you say shall, then it can't be a note.
It should be shall be taken. I don't, you see, the moment you put the note, it loses the flow, you don't see it, but those informations are needed at that time.
Then it has to be in the body.
Unless you move it completely on the back side, but if it's in the same page, just changing a font size and putting in a note really doesn't help. Okay, so I'm moving the note 1 and note 2, just making it a part of the
Yes.
standard.
That shall be there.